Hi, how are you doing? Welcome to today's lesson. What we're going to be looking at today is the second part of Pythagoras. Okay, so I've called this Pythag Theorem 2. Pythag Theorem 2, alright? Now the only reason why I've done that is to differentiate it from the very introduction of Pythag, where they were given the two straight sides and asked to find the hypotenuse. You should have watched that one first. Now, what we're going to be looking at today is what happens when they give us one of the straight sides and the hypotenuse and they say find the third side. Okay, find the other straight side. Now the reason why I'm separating this is because I found that year 7 and year 8, this is such a small difference, but it confuses the heck out of people initially until you get used to it. Okay, now hopefully I'll be able to clarify this in a second. So let's look at a nice Pythagorean triplet that we're going to look at now. So this is 4, this is 5, and they say how much is this? Let's call this y, okay, because it's the vertical. 4 centimeters, 5 centimeters, and it's a right angle triangle. Okay, so and we stop. We say, okay, great. Now I know that Pythagoras, this is my story with Pythagoras. Pythagoras says that r squared, the hypotenuse squared, equals x squared plus y squared. Alright? So the hypotenuse squared equals the two straight sides squared then added together. The sum of the squares of the straight sides. Right. So this is my story. Now the problem comes in is that what I get often is when kids see this, they take the 4 and they put it in there, perfect. But then they take the 5 and they put it in there and they add them together. Okay. Now this is where you have to be careful and where I always suggest, and it helps if you do this, I believe. Write down the equation, then substitute the numbers in the correct position before you do any working. Before you even think about calculating anything or even touching your calculator, write down the substitution. Okay, this will eliminate the mistake of putting these two together because in the Pythag you'll see they don't go together. So let's do that. Well, r is 5, so I've got 5 squared equals, so that's r. X is 4 squared plus y I don't know yet. Y squared. Let's just leave that as y squared. Are you with me? Now, this is important. If you put them in the right position, now hopefully you'll be able to see that I'm not adding 5 squared plus 4 squared. The most common mistake is I see 5 squared plus 4 squared and then they put them together here. But the 5 squared is not one of the straight sides. It's the hypotenuse. Okay, that's the important part. Right, so now this is an equation with one unknown. So what I'm going to do is I'm going to use BIDMAS backwards, and the opposite to the other side, opposite to other side to work out this equation. Okay, so let's do that. Firstly, let's tidy up those squares because they're hideous. So 5 squared is 25, equals 4 squared is 16 plus y squared. Right? Now the opposite of plus 16 is minus 16. 25 minus 16 equals y squared. 25 minus 16 is 9, equals y squared. Now the opposite of square is square root. So the square root of 9 is 3 equals y. So y is 3 centimeters. Are you with me? I just want to reiterate, because this happens over and over again in the beginning. Okay, if it's the hypotenuse, it has to be alone. If it's the two straight sides, they have to go together. Irrespective of whether they give you the hypotenuse as a number. Okay? It's very tempting, initially, before you get comfortable with this, to always put the letter part, the unknown, alone. So put y here equals 4 squared plus 5 squared. No. Irrespective of what they are, the two straight sides have to go together. The hypotenuse goes alone. Alright, so let's look at e.g. number 2. Because this one is what I was talking about on the previous video about having not nice numbers. So e.g. number 2, I'm just going to go a little bit quicker about this because we've spoken about this already. So let's look at some hideous numbers. 7.9 centimeters, 3.2 centimeters, and they say how long is c? They called it c. Okay? No worries. First step, Pythag. Write it down before you do the substitution. R squared equals x squared plus y squared. There's Pythagoras. Now I'm going to substitute into that. So r, well, I've called r c squared equals, I've called x was 7.9 squared plus y is 3.2 squared equals, right? So now what I'm going to do is I'm going to work this out in a calculator, and I get 72.65. That is c squared, not c. So to work out what c is, I have to do the opposite of square, is the square root. 72 square root of 72.65 gives me 8.5 centimeters, and I've rounded this to 2 decimal places and then 1 decimal place respectively. Okay, alrighty. So you got to check also your accuracy, because I'll ask you what is the value of c to 1 decimal place, or what is the value of c to 3 decimal places, because when you square root, you'll usually get a long decimal that happens after this. Okay, most of the time. Alright. So that's the one story where I've got not nice numbers, but it's okay because we can use a calculator for this one. This one would have to be in a calculator test. Alright, there is no way I can imagine that you'd be able to do this one without a calculator by hand at the level that this is asking you. Okay, last example before we sign off for today, EG3. Alright, and they said find the length of C to 1 decimal place. Now, look, just be careful with this. This is the right angle. I haven't drawn this to scale, okay? Now they've said that this is 7.9 centimeters, and this is 3.2 centimeters, and this is C. Now, this is not the same situation as this. The numbers might be the same, the variable might be the same, but it's not the same situation. In this situation, C is opposite the right angle, so that makes it the hypotenuse, so it goes alone. In this situation, the 7.9 is opposite the right angle, so that makes this the hypotenuse. Are you with me? So, first step, Pythag. R squared equals x squared plus y squared. Now, where do things go? Okay? Well, the 7.9 is the hypotenuse. It's opposite the right angle, so that's 7.9 squared, the hypotenuse, equals x squared. Well, I don't really know which one's x and which one's y. Let's call this one x squared, 3.2 centimeters, plus y squared, let's call this c squared. Because it's not in the right position, it's not in the first position. You'll get to that when you get more into trig. Okay, looks like it's almost in the third quadrant. Okay, or second quadrant. All right, so there it is. Okay, so now what we're going to do is we're going to work out c. But now this is a variation of where the hypotenuse is on one side, and one of the unknowns is in the straight side. No worries. Square this. All right. So 7.9 squared is 62.41. 62.41 equals 3.2 squared is 10.24. 10.24 plus c squared. Opposite plus 10.24 is minus 10.24. So 62.41 minus 10.24 is 52.17 equals c squared. Opposite square is square root. If I square root 52.17, I get c equals 7.2 centimeters. With me? Okay. So, just be careful with this. Just be careful. The main thing you must worry about is what are the things that I'm looking at. Okay? Once you've isolated your hypotenuse, whether your hypotenuse is given to you and you have to work out one of the straight sides, or whether your hypotenuse is the unknown and you have to work it out using normal Pythag, shouldn't be an issue if you write down Pythag and substitute accordingly. This is the thing that I find a lot of year 7, year 8, and even some year 9s get a little bit confused with. Where do I put the number? Okay? Well, it depends where it is on your triangle. Okay? Come watch this again, especially if you find that you're getting a couple of Pythagoras questions wrong. Okay? This is the second level of Pythagoras before you start getting into harder things. You should be okay with this, even, please, before you get to trig, you should be okay with this. Alright, okay, come watch this again. Remember, I'm here for you.